Now another very important technique is there also. In previous classes I have discussed LPP with the help of graphical method. There is another method that is known as the algebraic method, not much popular like graphical and simplex method, but we have to understand how a problem can be solved with the help of this algebraic method and what are the limitations of this algebraic method, so that it is not much popular. What are the disadvantages of this method? That's why this is not much popular, right? So in today class, the today class theme is we will understand how a LPP can be solved with the help of algebraic method, right? To understand this algebraic method, I am considering a product mix problem. First I will solve this problem with the help of graphical method. Then the same problem I will solve with the help of algebraic method, so that we are easily understand what is the basic behind this algebraic method and what are the limitation or what are the disadvantage of this algebraic method. That's why it is not much popular in comparison of graphical method and simplex method, right? So we are considering a problem. It is a product mix problem. A small manufacturer making two product A and B, and the problem is given into the description form. Firstly we have to convert into the mathematical form, and any description is converted into the mathematical form is called as transformation, right? So how we can convert? Firstly we have to check, but we have to decide the decision variable. How we can decide the decision variable? On the basis of the requirement of the question. In previous lecture so many times I have discussed, on the basis of requirement of the question we can select, we can choose proper decision variable and objective function. So the requirement of the question is how much manufacturer should produce product A and B to maximize his profit. So what are the decision variable? Product A produce X, product B produce Y. These are the decision variables. We can easily identify these are the decision variables. And what is the objective function? Objective function is belongs to the maximization, and we have to maximize the profit. And in question, what are the restriction given? So restriction is given in the form of a statement. Sometimes the restriction given in the form of tables. In previous numericals we have seen generally the descriptions and the restrictions is given in the form of tabular form. So it may be also in description form. There are two resources, R1 and R2 are required to make these product. Each unit of product required to produce product A, 1 unit of R1 is required and 3 unit of R2 is required, right? If you want to write for the R1, this is product A and this is product B. This way you can form a table so that you are easily convert description into the mathematical form. So this is the product A, this is the product B, this is for R1, this is for R2. And how much? This is 1 unit for R1, this is 1 unit for R1 for product A, and 3 unit of R2 for product A. And same way there is a each unit of produce B required 1 unit of R1 and 2 unit of R2. And here is the limitation, restriction is given. Resource restriction is given here in this statement. The manufacturer has 5 units of R1 and 12 unit of R2 available. So these are the maximum unit available to us. Maximum unit of R1 is available 5. So maximum is the indication of the maximum, then the constraint of less than and equal to type. Maximum of R2 is 12. So the maximum filling is here. Maximum means the constraint of less than or equal to. If the filling of minimum, then always constraint of greater than or equal to type. If the filling of exact, then the constraint is always of equal to type, right? So I have taken x1 is here and y, sorry, not x1, I am representing x and y here, right? So I can write x plus y, right? So these are the restrictions, these are the limitation. And what is the objective function? The objective function of maximization type, the problem belongs to the maximization type and we have to maximize Z maximum, that 6 per unit to produce A sold. We are getting a benefit of 6 per unit if we are producing A. So how many we are producing? X. So 6x, and we are getting a profit of 5 per unit if we are producing product B on selling, that is, and we are producing Y, so that is 5 into Y. So that is the objective function. These are the constraint number 1, constraint number 2, and non-negativity restriction. Non-negativity restriction. What are that non-negativity restriction? We have to write all decision variables are greater than or equal to 0. There are 2 decision variables, right? We are taking 2 by 2 problem so that we are able to understand graphically, and then we will solve this problem with the help of algebraic method, right? So graphically we can easily plot it, there is no doubt about it. So many problems we have already discussed, right? Just we have to write the coordinate of these equation. Once we write the coordinate of the equation, plot on the graph, and we will find the feasible region, and at the corner point of the feasible region, because this problem belongs to the maximization, we have to see the maximized corner point, and we will get the optimal solution, right? So here is the same way we are assuming, the description is here, right? We are assuming X is the number of unit, Y with the number of unit produced of the product B, and Z is the profit, right? So I have already discussed all the things. That is for equation for R1, that is for equation for R2, resource 1, resource 2, and these are the non-negativity restriction, and we are getting the solution by plotting on the graph. Simply we can plot a graph. Suppose the coordinate of this equation is 5, 5. How we are getting coordinate? Just put x is equal to 0, we are getting y is equal to 5. If we are putting x is equal to 0, then we are getting y is equal to 0, we are getting x is equal to 5. Same way, if we are putting y is equal to 0, we are getting 4. If we are putting y is equal to 0, x is equal to 0, we are getting 6. And we can easily plot. Suppose 1 centimeter is equal to 1 unit. 1, 2, 3, 4, 5, 6. We have to keep a scale and marking 1 centimeter is equal to 1 unit. Again here, this is x, this is y. 1, 2, 3, 4, 5, 6. So first is 5, 5. Suppose 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 5, 5 means we have to plot here 5, 5. And the solution, this equation is of less than type, means the exact solution will lie below this, because the constraint of less than type, right? Next equation is 4:6. This is the equation of 4:6, and again the solution lie in this side. So we can say simply the solution is, we can easily say solution is, the common feasible region for both the equation is this, that is the feasible region. And what are the, because this problem belongs to the maximization, what are the feasible region corner points? Corner point number 1, corner point number 2, and the corner point number 3. So that is point A, that is point B, that is point C. So we have 3 different corner point. So we have to calculate the value of the corner point. If we are getting, suppose this point is, not suppose, this point is 4, 0, and C point is 5, 0, 0, 5, sorry, this point is 0, 4, x is 0, at this point x is 0, y is 4, at this point, and this is the equation is 5, 0, and this point is intersection of both the line, right? Here the point B is representing intersection of both. So we can solve these 2 equations. Easily we can solve algebraic, right? 2 equation, 2 unknown, easily we can solve it. If we are solving just like this, we can easily solve. If I put just multiply by 3 here, 3 into 3 and minus this, so this is cancel, that become y, that become how much? 3. So y is equal to 3, if I put here, so x is equal to 2. So the coordinate of this equation is 2 and 3. Now I put all these 3 corner point into the objective function equation. The objective function equation is 6x plus 5y. 6x plus 5y. I have to put all these value. First for a, z a, 6 into 0, plus 5 into 4, that become 20. ZB 2 into 3, 6 into 2, 12, plus 5 into 3, 15, that become 27. And ZC, the C point is 5 into 0, so 30, that become, that is 5 0, so that become that point is 5 0, so we are getting a value less than this. So this is the value at which we are getting the maximum value. So solution of the problem is 27, right? So this way we can solve the problem, right? So simply we can solve this problem with the graphical method and obtaining the optimal value, right? And that is x 0, y 0. So the solution of the problem is this, right? So we are getting here, so this value is 5, this value is 4, so we are getting here, you can say this is 4 0 and this is 5, this is 0 5, and here is a 4, is a 5, so we are getting here 25, that is 5 or 24, and we are getting 25 here, right? So there is a small correction, right? The coordinate of this point is 5 5, and I have plotted against, just like this is the, just like the solution we can obtain here. The solution is 4 and 6 here. I have plotted the wrong line, and so, and this is 5 and this is 5. This is the feasible region. So in this feasible region there are 3 corner points. One is here, so one corner point is representing 0 5, and that is the intersection of both the line, and we have obtained the coordinate 2 3, and the third coordinate is 4 0. If we put all these 3 corner points into the equation, 6x plus 5y, at this point the value of z is 25, at this point the value of z is equal to 27, at this point the z value is 24, and the maximum of these 3 values is 27. So this point is the optimum value, right? So this way graphical method can be solved. We can solve graphical method this way, right? So many times, so many problems we have seen for the graphical method. Now we are interested to see the algebraic method. We are considering the same problem. By considering the same problem, we will see how this problem can be solved with the help of algebraic method, right? So the same problem we are taking objective function, maximization, constraint number 1, constraint number 2, and the non-negativity restriction, and we have to solve this problem with the help of algebraic method. So how we can solve? Firstly, we have to convert, first step to solve any problem with the help of algebraic method, we have to convert constraint into the equations. Equalities means constraint into the equalities. When we are converting constraint into the equalities, so we have to add slack variables. We have to use some variables that is known as slack and surplus. If the constraint of less than and greater than type, then always use slack variable. If the constraint of greater than and equal to type, then always use surplus variable, right? Just like this. Here the equation is given, objective function is this, and we have a equation, try to understand, we have a equation just like x1 plus x2 is less than equal to, now the equation, if I am taking a note in the terms of xy, x1 x2, 6x1 plus 5x2, that is the objective function of maximization type, and the constraint are restriction are x1 plus x2 is less than equal to 5, and that is second one 3x1 plus 2x2 is less than equal to 12, and the non-negativity restrictions 12. Non-negativity restriction is x1 and x2 is greater than equal to 0. So now the equation, we have this equation, right? Now we can easily see this left hand side is less than equal to right hand side. If I want to keep left hand side is equal to right hand side, then we have to add something in left hand side, right? It is clearly mentioned here कि this ये जो left hand side, this is left hand side is less than the right hand side. So if I want to make a equalities, if I want to convert into the equality, I have to add another variable. So I have add another variable. I put x1 plus x2 plus s1. This s1 is known as slack variable. This s1 is known as slack variable. Slack variable. And the if I am talking about the objective of the main function of these slack variables, just convert equalities into the equations, right? They do not contributing in the objective function, means there is no contribution in the objective function. They will not affect the profit and loss, only converting inequalities into the equalities, right? So that's why in objective function the coefficient of these slack variable is 0, right? Because they are not contributing in the objective function. The maximization of the objective function before prior converting into the equations, the objective function is same, because 0 will not contribute in the objective function. We are using this slack variable only to convert inequalities into the equations, inequalities, right? Same way for the second equation we can put another variable, another slack variable s2. And now the non-negativity restriction, because the number of variable before 2, now the number of variable is 4, because we have introduced two another variable s1 and s2, two slack variables. So the number of variable is 4. So non-negativity restriction always says all decision variables must be greater than and equal to 0. All variables must be greater than equal to 0, right? Now the problem become 4 variable problem, right? When the problem become 4 variable, how we can solve these problem with the help of algebraic method? We have to decide. Now the number of variable is equal to 4 and number of equation is equal to 2, and n minus m, that is equal to 4 minus 2 is equal to 2. We have to consider two variable as a non-basic variable. Are you getting my point? Now the problem become number of variable is 4, right? Now the variable are 4, x1, x2, s1, s2. Number of equation is same as m is equal to 2. The term n minus m always represent number of non-basic variable. The meaning of non-basic variable, we have to fix these non-basic variable to any arbitrary value. If we are fixing these non-basic variable to any arbitrary value, so there are infinite number of solution, because arbitrary value may be 0, 1, 2, 3, 4, any arbitrary value can be taken as. If I am taking any arbitrary value, so there are infinite number of solution. That's why I am fixing these non-basic variable, or I can say the arbitrary value, to the 0, so that I am able to find out the finite number of solution. I am repeating my statement again. These non-basic variable can be fixed to any arbitrary value. If I am fixing this non-basic variable to any arbitrary value, then the problem has infinite number of solution. If the problem has infinite number of solution, so how I will obtain an optimal solution? That is very difficult to get the optimal solution. So there is a need to fix arbitrary value to as 0. I am considering arbitrary value as a 0, so that if I fix arbitrary value as a 0, then this problem has a finite solution. Because how many solution, how many combination of the variable is possible? 4C2 NCM. How many possible combination are available with the 2 variable problem, or I can say 4 variable problem? 4C2. If I solve this 4, this is 4 factorial upon 2 factorial upon 2 factorial. So that become 6 possible number of possible combination. 6 number of combination is available with basic and non-basic variable. A variable that is fixed to the 0 is known as non-basic variable, and the variable is calculating with respect to these non-basic variables is known as basic variables. Means 2 variables at a time is non-basic and 2 variable at a time is basic variable. And the solution obtained by keeping 2 variable as 0, arbitrary value as 0 or non-basic variable, the solution obtained is known as basic optimal solution. Basic optimal solution. So that is the basic behind the algebraic method. Now we will solve this problem with the help of algebraic method. So we have easily understand there are 6 possible combination by which we can solve this algebraic problem. How? We are considering at a time 2 is non-basic, means 0 value, and we will obtain by keeping these 2 variable, because this problem belongs to the 4 variables problem. If at a time 2 variable is 0, so easily we are able to calculate 2 another values, because we have 2 equations as well as, right. So this way we can make the different, how many combination, how many different arrangement are possible? There are 6 possible arrangements are there. We can decide on the basis of just like NCM, 4 factorial upon 2 factorial upon 2 factorial, and we are getting the value 6. So we can see in the next slides. So all these things are written here. I have already dictated to you. So going to the solution directly. So we can see the solution of this problem. I am writing so that we can easily understand. The objective function is z. The value of the objective function is 6x1 plus 5y1. Constraint is plus 0s1 plus 0s2. Constraint 1 is x1 plus x2 plus s1 is equal to 5. Constraint 2 is 3x1 plus 2x2 plus s2 is equal to 12. Right. Now this column is representing non-basic variable, this column is representing basic variable. Other than non-basic is known as basic variable. What is the meaning of non-basic variable? We will put every time 0, 0. We have taken a arbitrary value 0. Why we are taking arbitrary value 0? So that we are able to find a finite number of solution. Because arbitrary value can be anyone, anything. It may be 0, 1, 2, 3, any number can be an arbitrary value. If we are free to take any arbitrary value, so the problem has infinite number of solution. So to get the finite number of solution, we are fixing that arbitrary value to a 0. So every time I am taking the 6 different combination, 1, 2, 3, 4, 5, 6. These are the 6 different combination of the decision variables, non-basic variables. We are fixing 0. By fixing these non-variables 0, we are able to get the basic variables, and we are getting to that basic solutions. Right? Okay. If I am putting in these two equation, x1 is 0, x1 or x2 is 0, so I will get s1, s2. What is the value? s1 is equal to 5 from this equation, and s2 is equal to 12. If the solution is s1 is equal to 5 and s2 is equal to 12, the value of objective function will be 0. And this column is representing, I can say I just plot a graph. I have already plotted a graph for this, and this graph is just like this. This is the line of 5, 5, and this is the line of 6 and 4. This is 4 here, and this is 5 here, and this is 6 here, and this is 5. So that is the solution of the problem. So this point is representing z is 0, matlab a. On the graph, the point is representing a here. So we can represent also graph. Region is feasible, there is no doubt about it, and z value is 0. Right? Now we have changed the combination. We are taking x1 is equal to 0. In this equation, we are taking x1 is equal to 0. and S1 is equal to, if we are taking X1 or S1 is equal to 0, so X2 and X2 will be 5 and S2 will be 2. When S2 and X2 is equal to 5, the corner point is V. We are able to obtain a corner point B and the feasible region is yes. We are in the feasible region and the value of objective function is 25. So that point is V. What is the point V? This is the B point. So this value is representing as a point B. This is the B point, this is A point in the graph. The solution is coming. With the help of algebraic method, the solution is coming also can be represented on the graph so that we are able to compare between both the methods. How we are getting the solution in the algebraic method. In the third combination, we are putting x1 is equal to 0, s2 is equal to 0 and we are getting s2, s1. We are getting s2, 6, s1, minus 1. As soon as we are getting a negative basic solution, it means that violates the non-negativity restriction, because non-negativity restriction said all variables must be greater than or equal to 0, and here S1 is negative. If S1 is not greater than or equal to 0, then this corner point does not have any solution, means there is no feasible region. So that's why there is no feasible region, and there is no feasible region and this corner point exists here. You can, if you want to plot, you can represent here this point E, and obviously we can see here this is not a feasible region. This is not a feasible region. That's why in the graph this point is coming, because this point has no feasible region, right? So if this corner point does not have any feasible region, no need to calculate the value of objective function at this point, because this region is not feasible region. Solution of a problem must be satisfy all the constraint and non-negativity restriction. Then you can say that that is the solution of the problem. Otherwise, it can't. So in the next combination, we are putting x2 and s1 is equal to 0 and we are getting x1 and s2, 5 minus 3. Again the same thing, minus 3. S2 is negative. As long as S2 is negative, it means that violates the non-negativity restriction. If it violates the non-negativity restriction, it is also not the feasible region, and this point is representing F. This point is here F. But we can easily see in the graph this point F is not associated with the feasible region. So that's why at this point again we are not calculating the value of Z. Another combination, if I am taking x2 is equal to 0 on basic variable, s2 is non-basic variable, getting the value of x1 and s1. The coordinate come 4 and 1. When the coordinate come 4 and 1, this is representing the point D. This point D, and this is the boundary of a feasible region, and it is at corner point, right? And this point has a feasible region, and the value of Z is, I am just putting 6 into 4 because S1 is 0, right? So the value is 24. Again, if I am putting S1 and S2 is equal to 0 in this equation, if I am putting S1 and S2 is equal to 0, and by solving these two equations I am getting the coordinate 2 and 3. X1 and X2 will be 2 and 3, and that point is representing C point on the curve. That point is C point on the curve. Intersection of both the line. Intersection of both the line, and the value of Z is, if I am putting x1 is equal to 2, x2 is equal to, this is x1, this is x2. X2 is equal to 3, so I will get 27, and this is the optimal solution. So this way we can solve any algebraic problem. We can solve any LPP with the help of algebraic method, and out of these the maximum value of Z is 27. So this is the solution. When we solve this problem with the help of graphical method, the same solution we obtained. With the graphical method, the same solution we obtained. With the algebraic method, the same solution will be obtained. If we solve this problem with the help of simplex method, again the same solution will obtain. Now we have to understand what are the difficulties, what are the limitations, what are the disadvantages of this method. Disadvantage number one, if I am comparing with the graphical method, only with the graphical method, till now we have studied the graphical method. What are the disadvantages with respect to the graphical method? In graphical method, we only calculated value of z at 3 corner point. Which corner point? Feasible region corner point. Just like we have calculated value at this point, we have calculated value at this point, we have calculated value at this point. When we solve this problem with the help of graphical method, only at 3 corner point we have calculated the value of z. But in algebraic method, we have calculated at the more than 3 corner points. We have calculated at the 6 different points. So the first disadvantage, we are calculating optimum value, right, more than the graphical point, more than corner graphical points, because in graphical method we have calculated only at the 3 different points. Here we are calculating at the 6 different points. So large number of corner point we are calculating the value, right? So definitely the method is not suitable. Second one, we can observe easily, it is inconsistent in the output. Means first we are getting value 0, second we are getting 25, then we are getting 24, then we are getting 20. There is a inconsistent, means the value is not increasing order. We are not obtaining optimal value in an increasing order. At random any value can arise. Means the successiveness of the solution does not say that we are moving in the direction of optimal solution, right? The second disadvantage of this algebraic method is this. Third one, we have calculated value in infeasible region also. Unnecessarily we are calculated for infeasible region. We do not interested to calculate for unfeasible region, because if the region is not feasible, the obtained solution will never be the solution of the problem, because solution of the problem is the solution that always satisfy all the constraint and non-negativity restriction. And here at 2 different point the solution is infeasible. If the solution is infeasible, we never calculate it. In graphical method, we always calculated only for the feasible region. We never calculated for the infeasible region. But in algebraic method, we are bound to calculate for infeasible region as also. So that is the another disadvantage of this method. And also, there is no termination criteria. In algebraic method, until unless we are not calculating for all the combinations, all the possible combination, we cannot terminate the problem, right? So there are number of disadvantages. That's why this method is less popular comparison of graphical and simplex method. A method which will be the better than of this algebraic method if it contains always there is a succession of the problem, successive solution of the problem guarantees the optimal values, means better values. Suppose first value comes 0, second comes 24, third comes 25, fourth comes 26. If the successive order of the solution of the problem is like this, so a method is always better than this algebraic method. If we do not calculate for non-feasible region, if we are not calculating value for the non-feasible region, the method is always better than the algebraic method. And if we have a guarantee, if we have a termination criteria, as long as we reach to the optimal value, the problem itself say we have reached to the termination. Now there is a need to terminate the problem. We have reached to the optimal value. A method is always better than the algebraic method if it has a criteria of termination. and that all quality come into the simplex method. That's why simplex method is the most powerful tool for this LPP problem. We can solve any problem with the help of graph method, we can solve algebraic method, we can solve simplex method. Any type of LPP can be solved with the help of simplex method. But graphical method has limitation, only 2 variable problem can be solved. And this algebraic method has a lot of limitation, right? Because we have seen the lot of disadvantage of this algebraic method. If algebraic method has a lot of disadvantages, I have already mentioned, so definitely that's why it is not much popular, right? So we can understand all these things. All the whatever I have discussed is written in the slides. We can read out. I have already predicted all the things and method, right? And the disadvantages. It evaluates a large number of solutions in comparison of simplex and graphical method. Graphical we have seen, already we have mentioned. And out of the number of large number of, some of them could be infeasible ones. And we are not interested for the infeasible values, infeasible solutions. And also the successive solution does not guarantee the continuous improvement. And also it does not have any mechanism that we have reached to the optimal value or the optimal value arrived, until unless we are not solving the complete combination of the problem. Suppose if the variables is 6, suppose the variable is 6 and the equation is 2. So how many possible combination? 6 factorial, 4 factorial and 2 factorial. How we can write? 6 into 5 into 4 factorial divided by 4 factorial into 2 factorial. 15. We have 15 number of possible combination. Until unless we are not solving 15 combination of the problem, we are unable to stop the problem. Even we have a optimal solution, we have already calculated optimal solution. So that is, there are these disadvantage of this methods, that's why it is not much in popular. A method is more popular than this method if it will overcome all these difficulties. Means a method will be the better than the method if we are not calculating large number of solution. If that guarantees the successive solution will be the improvement, continuous improvement, and also has a termination criteria. That method is known as simplex method. In next class I will discuss the simplex method, right? So a method is always better than this algebraic method. It should not evaluate infeasible solution. It should be capable of giving progressive better solution, and the moment has found the optimum value, it should terminate the problem. So a method is better than the algebraic, that method is known as the simplex method. In next class I will discuss. Thank you.